This video is still on lesson 5.1, but these are going to be the problems that just ask you to simplify using the rules of exponents. So they don't specify which ones you're going to need in order to simplify these expressions. So we're going to take a look at number 40 first. And in this one, the first thing to do would be to take care of these exponents that are on the outside of this group of parentheses. So to do that, again, this is that product to power rule, and then eventually we're going to be using the power to power rule. So to get us started, again, we're going to use the product to power rule. So we're going to rewrite this as m to the third times n squared to the third. And then over here, we're going to be distributing the squared to both parts of this factor. So we're going to have m squared squared times n to the fifth squared. Now we're going to use that the power to power rule. And this one, now we're going to multiply our exponents. That's what the power to power rule says. So this is going to be m to the ninth times n squared to the third is going to be n to the sixth times m to the fourth times n to the 10th. Just like before, we'll take the time to rewrite this so that our bases that are the same are next to each other. So we'll write this as m to the ninth times m to the fourth times n to the sixth times n to the 10th. Just so that way when we go through and use this next rule, our product rule, we can see that our bases that are alike are right next to each other. So the product rule again tells us to add the exponents to simplify these. So m to the ninth times m to the fourth is going to be m to the 13th. And n to the 6th times n to the 10th is going to be n to the 16th. And that would be our final answer for that problem. So that's the simplified expression. 42 is a little bit more involved. Just like before, I would write this out so that this is a little bit more expanded and not so condensed on the top. So if we rewrite this out, we're going to have 18 times c to the 0 times d to the 10th times, because again, we can lose the parentheses since this is all multiplication on the top, 4, and then times c to the 5th times d squared. And this is all over 12 times c times d to the 5th. So now going through this problem, this c to the 0 hopefully stood out to you. This is not going to even be really part of this because c to the 0 power equals 1. So anything times 1 is just going to be itself. So that's really not needed. So we can ignore that as we go through these next steps. So just like the previous problem, I'm going to take the time to rewrite it so that the terms that are alike are next to each other, the different factor terms that are alike. So we're going to have 18 times 4, so I'm going to rewrite those constant factors next to each other, times c to the 5th times d to the 10th times d squared. If you haven't noticed in a lot of these problems, I rewrite it so that it's alphabetical. That is technically the way that you are to write these expressions. So typically your constant's out front, that coefficient, and then it's followed by the variables in alphabetical order. When we get to polynomials, we'll talk a little bit more about the ordering process, and it also has to do with the degree as well if you do have the same variable. But like I said, that's all going to come up later in chapter 5. So it's just kind of a good thing to keep in mind that if you're wondering why I keep writing it so that it's an alphabetical like the previous problem, m and then n, this one I rearranged it so that it was c and then d. It's because technically the variables should be in alphabetical. So back to this problem, the bottom we can't do anything with right now until we end up applying the quotient rule. So that's just coming along for the ride as we go through and simplify the top. So to simplify the top, we can actually do 18 times 4. So 18 times 4 is 72. C to the 5th has nothing to combine with at this point. D to the 10th times d squared, though, that's going to be incorporating that product rule. So this is going to turn into d to the 12th. And this, again, is all over this 12 times c times d to the 5th. At this point, we're going to now use the quotient rule. And this will actually be the final step in this question. So 72 divided by 12 is 6, so that's going to turn into 6. C to the 5th divided by c, again, remember there's a 1 on this variable, so we're going to subtract those. 5 minus 1 is 4, so this is going to be c to the 4th. And then d to the 12th over d to the 5th Again, we'll subtract those exponents. 12 minus 5 is 7, so this will be d to the 7. And that's our simplified expression. So this entire expression here turns out to be just this small expression here after we simplify. This last example, number 44, is going to be a little bit more involved, but again, start with that exponent. And this exponent, again, is going to be that quotient-to-power rule. So we're going to take this squared, and we're basically distribute to both the top and the bottom part of this quotient. So we're going to write this in parentheses. So we're going to write this as negative 2ac squared all squared over, and then b to the third squared. And then we can go ahead and lose the parentheses over here and just rewrite this as 9a to the 5th times b to the 8th all over c to the 3rd. So now at this point, we are going to go through and use that product to power rule to simplify this part, and then we'll go ahead and also do the power to power rule on the bottom to simplify that. And this side we really can't do anything with yet, so if you're wondering why we're not focusing on this, it's because there really isn't any simplifying you can do over here until we get to this point and have this simplified. So this is going to be basically distributed to each part of this factor. So negative 2 squared times a squared, and then c squared squared. And then, like I said, we'll go ahead and simplify this bottom part. So 3 times 2 is 6, so this turns into b to the 6th. And this is all being multiplied again by that 9a to the 5th, b to the 8th, over c cubed. Now, we're going to go ahead and simplify this even more. So we're going to simplify this negative 2 squared is going to turn into 4. So we're going to have 4, and then times a squared times c to the 4th, because again, we're going to multiply those. And then that's all over b to the 6th, and this is times, again, this 9a to the 5th, b to the 8th, over c cubed. Moving forward, we can actually multiply these together to make one giant quotient. So we're going to go ahead and do that. So we're going to rewrite this as 4 times a squared times c to the 4th times 9 times a to the 5th times b to the 8th all over b to the 6th times c to the 3rd. Moving forward with this, looking for what we can actually multiply together. So we can do 4 times 9, that's going to be 36. We can actually do the product rule for the a bases, and we'll add those exponents. So this top is going to simplify down into 4 times 9, which is 36. A squared times a to the 5th is going to be a to the 7th. Then we're going to have b to the 8th and c to the 4th. And that's all over b to the 6th times c cubed. And if we want to, we can still leave those multiplication dots on the top since we're not at the point where we have our final answer. We just have one more step to go, and that's because we have bases that are the same on the top and bottom of this quotient. So we do need to simplify both of these parts here. And so this is going to end up simplifying down to our final answer. So 36a to the 7th, b to the 8th over b to the 6th. We'll subtract those. This will turn into b squared. And then this will just be c because 4 minus 3 is 1, and we really don't need to write the 1 exponent. So that is our final expression for number 44.